Hello, sixth grade. This is lesson 80, transformations. Now come on, how many of you were into Transformers way back when? Yeah, Optimus Prime and all that good stuff. Yeah, it's kind of the same, but maybe a little different. All right. So when we talk about transformations in math, what we're doing is changing the position, the size, or the orientation of a figure. And we're moving something around, we're making it bigger, we're rotating it, we're turning it, we're flipping it, and to do that correctly, you got to follow instructions. And you have to understand some vocabulary. So here's the vocabulary and what means what, all right? We talk about the movement of what you're doing in normal language, and then we translate that into its mathematical name, what it gets called in like homework and tests and when you deal with it mathematically, all right? So when we talk about moving something, we can talk about flipping an object, all right? We can take this piece of rectangle, all right, and we can flip it over to the other side, all right? Notice that there's just one line here and it gets flipped over that line. All right, or we can flip it above the line or below the line. All right, so here we have this axis that we are flipping it on, and when we talk about flipping something in math, we're talking about a reflection. We reflect something over, across, about some sort of an axis. We reflect it just like a mirror. If you've got this rectangle here, and I've got this axis of reflection, then if I were to flip it over this way, the axis would be on the other side, but it would be exactly in the same position, just flipped around. All right? So that's the idea of a reflection. Another way you can move things in math is to slide them around. You can slide things right, left, up, or down. And that's called a translation, where you simply start at one place and you move it 2 up and 3 over, all right? We can turn things, all right? We can take this rectangle and we can turn it around here, 90 degrees, 180 degrees, to something degrees, and 360, we're back to where we started. And that's a rotation, all right? And we can rotate things clockwise or counterclockwise, all right? They get rotated. Then we can enlarge something, increase its size from smaller to bigger, and that's called a dilation. Or we can shrink something, decrease its size, and that's called a reduction. And for both of these, we have something called a scale factor. And a factor, you will recall, is a number that's being multiplied. If you're dilating, you're multiplying by a number more than 1. If you're reducing, you're multiplying by a number less than 1, but more than 0. So if I want to reduce something by half, I multiply it by a half. All right? If I want to make it twice as big, I multiply by 2. And we'll get into that when we talk about dilation and reduction. But they use something called the scale factor. All right, so let's look at some of these, each of these types of problems that you would be asked to do, and show you how to do them. All right, so first of all, you want to use graph paper. All right, attached to this homework, you will find graph paper that you can use. I would definitely want to use graph paper on this. And you'll see things like triangle, RST has vertices, points, right? Point R is at 4, 3, S is at 4, 1, T is at 1, 1. All right? Draw triangle RST on graph paper and its reflection, the book says in the x-axis. Other books talk about the x-axis or over or under the x-axis. It's all the same. All right? Its reflection in the x-axis. All right? So you have a picture here of, here's the x-axis. And you've got some kind of a triangle, all right? And when you're done, it's going to get reflected over here so that it's going to look like the same triangle, except if you folded it and used the x-axis as the fold, it would match exactly. That's what we mean by a reflection. all right? You got the x-axis, you got a triangle here, and when you're done, its reflection will be the same distance above as below, so that if you were to fold it, it would match exactly. Let's look how to do that, all right? So here's our triangle, RST, and the points, all right? And we're going to reflect that about the x-axis. Here's the x-axis, all right? So that when we're done, we'll have something down here that if we folded it right at the x-axis, it would match exactly. And the way we do that is we look at this, say, point S here, and we see that it is exactly 1 unit above the x-axis. So that when we reflect it, it will be 1 unit below the x-axis. And so I will have a new point right there. Haven't changed the y at all right? Now this becomes the new point S, and for that we use a symbol which is a superscript, the opposite of sub, below. Super is above, superscript, and we put a little mark there above the S, and we call that S prime. And now we do the same thing with R. We see that R is 4 units above the x-axis, so when we're done, it will be 1, 2, 3, 4 units below the x-axis, and we'll call that R prime. And then T, we have 1 unit above the x-axis, so we'll put that 1 unit below the x-axis, and that will be T prime. Connect the triangle, and we see that we have a reflection about the x-axis. All right? And in fact, on some homeworks or future tests, you may be asked to list the coordinates of R prime, S prime, and T prime. Well, that's easy enough. S prime is still going to be 4, but now it's minus 1. R prime is still going to be 4, but now it's minus 3. And T prime is still going to be 1, except now it's going to be minus 1. So you notice what happened here, all right? We reflected it about the x-axis, and the only thing that changed were the y values became the opposite. Do you think that if I reflected it over the y-axis, the x values would become the opposite? You'd be correct, all right? A little pattern there you can pick up on to help you out with that. So that's a reflection. All right, let's translate now. Rectangle ABCD, 4 units down and 2 units left. So translation, that goes with slide. We're going to slide this thing down and to the left. All right, so we can pick a point, like point A, and I'm going to slide that 4 units down and 2 units to the left. So I start at A, and I go 1, 2, 3, 4 units down from where A started, and then 1, 2 units to the left. And that is A prime. All right, kind of like Optimus and Optimus Prime. Yeah. All right, so I got A prime. Now I do the same thing with B. I start with B, and I go 1, 2, 3, 4 units down, and 1, 2 units to the left, and there's B prime. C, I go 1, 2, 3, 4 units down, and 1, 2 units to the left, and there's C prime. And D, 1, 2, 3, 4 units down, 1, 2 units to the left, there's D prime. Connect the dots. And what do you know? I've taken this and slid it down and over just a little bit. That's a translation, 1 vertex at a time. Let's do a rotation, all right? Here we're to rotate triangle QRT 90 degrees clockwise, all right, the direction the second hand goes on a clock, about the origin. So in other words, I start at the origin, it's like I got a string attached to this triangle, and I'm rotating it 90 degrees, all right? And so I draw this little 90-degree sign here, and so I take point T, and now I've rotated T 90 degrees, all right? And then I've got R and Q to rotate as well. I rotate this guy All right, so the best way to do this rotation, I have found, is with a piece of paper. All right, so that you take a piece of paper and trace over your triangle. All right. All right, see, so there's the triangle. And now I'm going to rotate it 90 degrees so that this line that's up is now going to be 90 degrees over. And so my new triangle is going to look, yeah, pretty much rotated over. Yeah, not like that. But here and now, 90 degrees, it's going to look like that. There we go. And so this becomes Q, R, and then T. There. They got rotated. And indeed, again, the best way to do that is about the origin, so the point where your rotation, your pivot, goes here 90 degrees. All right? So definitely you want to use a piece of paper to help you rotate that. Otherwise, it gets very messy, as you can see. Okay. All right, finally, we want to dilate rectangle ABCD with a scale factor of 3. All right. Now, what that means is this length is going to be 3 times longer, and this length is going to be 3 times longer, and that length is going to be 3 times longer. But if you just try to increase everything by 3, it's going to mess up. So here's a tip for scale factors. All right. Notice that we've got these points. So we're going to rotate, or we're not going to rotate, no, don't have to do that. We're going to increase this by a scale factor of 3. In other words, we're going to take the original x and y values of these points, and the new points, all right, are going to be 3x and 3y. Those are the primes, all right? So here, since I'm doing a scale factor of 3, I'm going to take all these numbers and multiply them by 3 to get the new points. So in other words, B prime here, which is now 2, 2, is going to be out here at 6, 6. C prime, which is at 2 minus 2, is going to be 6 minus 6. D, which is at minus 2 minus 2, multiplied by 3, is now going to be at minus 6 minus 6. And A minus 2, 2, multiplied by 3, minus 6 plus 6 are the new points. And I'm going to put those points on there. And basically what I see is a dilated square, just by multiplying each of those numbers by the scale factor. If I were going to shrink it, then I'd multiply it by a fraction. And each of these points would get multiplied by a fraction and would go down, and you'd wind up with a smaller object. All right? So give this a try. Again, you want to make sure you use graph paper. Do lesson 80, A to D, and make sure you use graph paper on that. Both, you can crank off as much graph paper as you want. I'll have it available for you online. And then 10 to 16, you can do that on graph paper or a separate sheet of paper, doesn't matter. So lesson 80, A to D, 10 to 16, and that should do it. See you later.